And good afternoon, everybody, and welcome back to Perspectives on Sustainable Development. I'm your host, Chris Whitehead, and today we're going to be talking about hyperscale data centers. Again, we did an episode on this earlier this year, and ever since that point, about 2 months ago or so, the topic has just absolutely taken off, and everywhere you go. Like I was at a Chamber of Commerce event this morning, in fact, and that's all anybody wants to talk about. And the community, I'll even call it furor, just anger is building up over this because there's a lot of questions out there, a lot of fears, and a lot of and also disinformation. So I really wanted to come back again and bring on a couple of experts to focus on the energy and grid points of this, as well as actually the water use. Because from an environmental perspective, I'd say those are probably the biggest areas you hear the most about and the biggest concerns I frankly have. And I think if we're going to make informed choices here on these topics, it's best to try to be as objective as we possibly can and start from a point of fact and go from there. And actually, we're taping this episode at the end of May. I think I've told everyone this, but I'm actually from southern New Jersey, and just a couple of days ago, Governor Sherrill in Jersey came out with what they're calling guardrails for data center development in the state. And Pennsylvania also just did something very similar as well. And I caught flack a month or two ago, frankly, for putting an op-ed out there proposing the same thing, that I didn't think moratoriums were the answer necessarily to this because they essentially give up local control of what's going to be a global issue. And I would like the guardrail model to work if possible. And I think informed policy is possible if, again, we take on all the objective impacts that are likely to happen from this. And in my 20 years plus, I've never encountered something with the level of investment, potential environmental impact, and also workforce impacts as data centers have. So it's really, really important that we get these right. But I'll just stop there for a second because I could go on forever on this topic. I want to bring on our guest today. In no particular order, we have Jeff Davis, Principal in Integral Consulting, and Abe Silverman from Johns Hopkins University. Fellows, if you both come on camera and sound, please. Pardon me. Hey, guys.
Hey,
How's
how's
it
it
going?
going?
Good. How are you guys doing?
Good.
Fantastic.
Awesome. If you can both take just 2, 3 minutes, give a little bit on your background and as to how you first started getting into the data centers topics.
Yeah, Jeff, you want to go ahead?
Sure. I'll go first. So, as Chris mentioned, I'm a principal at Integral Consulting. I also sit on the board of NGWA, National Groundwater Association, which is the largest uh, groundwater organization in the country and in the world. And although I've been involved in groundwater and water related issues for my 30 plus year career. But specifically with on the data centers, we started, and I lead a task force on data centers. We started it back in November, and it's made up of a number of different people and organizations, from scientists and engineers to uh, elected officials and regulators across the country. And so it's been really good to have such a great mix of people. Um, and, that's a big part of the work that I am involved in right now is in addressing data centers, data center development, data center operation, and as how it impacts water.
Well, fantastic. And Jeff, thank you again for coming on. and it's an important topic. And coming from an air guy, mostly, I have a lot of questions. So I'm sure others also have questions. Um, but before we get to that, actually, want to say a couple words as well, Ib.
Yeah, sure. So Abe Silverman, I'm a research scholar at Johns Hopkins University. And most of my career, I've actually been working on electricity market policy. Um, and I'm one of these people who sort of toils in the back corners of making the electric grid work and making sure that the price signals are right and we're driving the right kind of investment. And I've had a variety of different roles, both at the federal government, at state government, but most of my career has actually been in the private sector, working for generation owners and investors in the electric grid. But a couple of years ago, I left and moved to originally Columbia University and now Johns Hopkins University, where we basically work with states and other interested entities in figuring out how do we do this whole clean energy transition in an affordable manner. And while I would love to be talking about decarbonization policies and long-term decarbonization, every conversation now devolves into a conversation about data centers. I was at a conference yesterday where somebody said, how many people in the room have talked about data centers in the last 24 hours? And, about 3/4 of the room raised their hands. And then he said, and the other quarter of you are lying. So I really feel like that's where we are. And why? Because customers, particularly in the PJM region where I do a lot of my work, have been seeing incredible increases in their electric bills. We're talking 20% year over year bill increases, which just has a tremendous impact on people's quality of life.
Absolutely.
And so we really need to understand why. Why is that happening? How can we stop it from getting worse? Maybe how we can reverse some of it.
Yeah.
And kind of the conclusion we all come to is the only thing that matters today for affordability, reliability, and frankly, decarbonization is data centers, because everything else is a rounding error.
Yeah.
So anyway, that's sort of how I come to this, and really excited for today's conversation.
No, actually, thank you. That's a great point to start, and it's where I was going to go with it anyway, on that affordability piece. But I think before we get there, at one point I forgot to mention in the introduction is I think it's important to kind of define what we mean by data centers here. Data centers are nothing new. They're roughly 80 or so in New Jersey already, but they're small. Hyperscale data centers are really what we're talking about, and roughly speaking, those are anywhere from 10 to a couple hundred megawatts power, and then also oftentimes well over 1 million gallons a day of water usage. So going to back to your point, Abe, on affordability, we're going to do a little bit of a fact versus fiction here. Is it a fact that it's data centers that's driving up everyone's energy bills in PJM?
Yes, fact.
Follow up. What's causing that?
So yeah, let me lawyers and academics, I'm a trained lawyer, never answer questions like that because you always get yourself into trouble. So yes, data centers are driving up rates in PJM for retail consumers. But I think it's really important to recognize they are not the only thing driving up rates. And one of the really complicated, one of the ways in which this problem is really complicated is, I often think about, like, let's look at your electric bill. Your electric bill is approximately half state retail charges associated with the poles and wires that bring the electricity to your house, plus taxes and fees and clean energy standards. Like, that's the retail portion of your bill. Then there also is a wholesale portion of your bill, and that wholesale portion is also made up of various independent components. By far, the biggest is the cost of making electricity, on the spot market. So this is basically, you take the price of natural gas. You say a power generator needs 10 units of natural gas to make 1 megawatt hour of electricity. The price for electricity that day is 10 times the price of natural gas. So you can see we are, as an electricity sector, incredibly leveraged to the price of natural gas. That's about 2/3 of the wholesale component of the bill. We also have transmission costs. So these are not the wires connecting your house, but these are the big high voltage lines, you might see along a highway. And we also have this concept of capacity. And there is a separate market for capacity. What is capacity? It's the option payment that we, as a society, make to electric generators to make sure that they are ready to operate on a particular day, and it's sized to make sure that we have enough generation, enough supply in the right locations to supply our needs on the hottest and very coldest days with an acceptable reliability margin. So, think about it this way. We're seeing increases in the cost on the distribution side, largely because the inflation and an aging distribution grid. So that piece of the bill is going up. We're seeing really significant increases in transmission costs on the wholesale side. So that piece of the bill is going up. And then to make matters worse, the price of natural gas has been going up. So we've been seeing the energy portion of the bill also go up. But of all of those, the piece that has gotten the most attention, certainly in the PJM market, is this capacity piece, where, we went from record low prices 2 years ago to prices that have triggered a, tectonic revolution in how PJM runs its markets, and even whether PJM will continue to exist in a very, very short period of time. So, the more nuanced answer is that a lot of these things are going up in cost, so the bill is increasing. But then on top of all those smaller increases, you have this really big lump sum that's hitting customers all at once.
Yeah.
And, Chris, I should say, the story is different in different parts of the country.
That's a good point.
And this is really important to recognize. And, for your national viewers and even international, the United States doesn't really have one or two or even three big electricity markets. It really has 50. Each state kind of has its own policies. And there's a lot of things that vary across those areas, including just how much data center load is coming into the particular market and when it's going to start showing up. And one of the things that a regional market like PJM gives you is it gives you a view into the future.
Yeah.
So in a lot of ways, the price increases we're seeing in PJM are really transparent. It's also home to Data Center Alley. So we're looking 2 or 3 years into the future and we're setting prices for that time period. So we're kind of like looking out and seeing these hyperscale data centers come into the market.
Yeah, no, that's a great point. Interesting. Jeff, to the water aspect for a bit. I guess a good spot to start is, would you agree, actually, with my ballpark numbers, that a lot of these larger hyperscalers can be anywhere between 1 million to 5 million gallons every day?
Yeah, that's certainly true, Chris. But if we kind of back up a little bit, I mean, Abraham kind of touched on this. The topic of data centers really isn't, a technology story. It's really an infrastructure story. And as Abraham talked about, data centers are kind of sitting at the intersection of energy and land, but also water, and those have to work together to make these projects make sense, and so what's happening right now is that the demand for data centers is growing much faster than the underlying systems were ever designed for. Power, as Aaron has talked about, power is kind of getting a lot of the attention, and then land. But what I'm seeing quietly in a lot of places, water's become more of the limited factor. And what you're bringing up is, I think that's where the conversation is a little bit off, because people hear these big numbers, millions of gallons a day, thinking I drink 80 ounces of water a day, and you're talking about millions, and it sounds alarming. Okay. But that's not what determines impact. Okay? What actually matters is that when that water is needed and whether the system can handle it.
Interesting.
Water systems are built, just like on the electricity side, water systems are built around that peak demand, not averages. Okay. And data centers tend to use the most water, just like electricity. They tend to use the most water on, the hottest days when everything else is stretched. Okay. So the real issue isn't just water use, it's capacity. Okay. Can the system deliver the water reliability at peak conditions? And we're starting to see that. We're starting to see research done on that peak condition. And so in a lot of places, that's still an open question. Okay. So from an NGWA perspective, where I come from, we're not to be here for or against data centers. Okay. They're critical infrastructure. And the question is whether they're being planned in a way that protects, in my case, groundwater, and that it works with the system long term. So I like what you're doing here on this particular podcast, the truth versus fiction, because most of what we're debating right now isn't one or the other. Abraham said, "Oh, it depends." It depends on where the project is, how it's designed, and how well it's planned.
And that's exactly the point I wanted to try and hammer home with the fact versus fiction thing. That's really more of a nuance. And it does depend quite a bit on some of the things you were just alluding to there, Jeff. But I guess backing up a little bit too, can you talk, and you kind of touched on this, where generally does the water come from that's actually used in a data center?
Well, I would say the most, historically, it's come from municipal sources. So the data center comes in, they reach out to the municipality. I mean, that's how it happens here in Utah and in most of the country. They say this is where we're going to develop. We need water from the municipality, and the municipality goes, sure. Okay. How much do you need? And they look and they're like, oh, we average X amount of, water a day. And they're like, oh, yeah, we can do that. Yeah, that works. And so those sources, come from the same sources that a municipality is going to get it, whether it's groundwater or surface water or reservoirs that they're supplying their municipality. So that's generally where it comes from historically. Now, when we're talking about these really large demands, municipalities are like, oh, yeah, we can't do that. So, okay, you need to bring water. And it's the same. We're seeing that on the energy market. They're like, okay, you're going to have to bring the energy. So it's the same. But where it comes from the water that you and I use every day. That's generally historically been the case.
Yeah, Jeff, I was just listening to you talk and I was like, this is exactly the same discussion we're having on the electric side.
Yeah.
Yeah, totally.
Same issue.
And it's the same constraints, right? It's both the underlying supply, electrons versus molecules of water, and the delivery infrastructure. And both of them are potential choke points.
Exactly. And the main thing that I want to stress in this podcast, is it's the peak demand. And that message is not being heard enough. And it's the same on the energy side and it's the same on the water side. We really need to understand, and the data centers development need to be transparent on that peak demand, because that's really what's going to have to happen on the planning side.
Interesting. And I've been fortunate to be able to tour a couple of these larger facilities over the last couple of years. And one thing that always struck me was the goal to always innovate and find better ways of doing things. And um, I'm I'm not sure how to put this part, but I'm going to say it anyway. The people who run these places are not dumb. They're trying to find the most efficient ways of operating, and the scale of it is new and daunting. I think a lot of folks, but I guess I'll throw another factor fiction out there. Given what you both know about the energy and water aspects of this, is the level of alarm justified, or is the push for moratoriums, in your opinion, the way to go on this? And I agree with something that Jeff said, that I'm not for or against. I try to play this down the middle and try to help people towards better policies. And because it's such a global issue, hypothetically, if you're not building a data center here, it's going to go in another place and still have the same effect on the larger markets.
Sure. Yeah. I mean, it's a NIMBY thing. We see that, across the country. My perspective, Chris, is like I am so happy to see people being passionate and being involved and learning, So that's great because that just puts the pressure on innovation and working together, and you see this pushback, in a lot of different areas. And great, because it challenges the current system and it challenges, you know, the pushback is generally from a sustainability point of view, right? It's like, how is this sustainable? Okay, let's tackle that problem. Let's tackle that challenge. And I see that happening. I mean, they have very smart people, and they realize if they're going to continue to grow, they've got to look at better ways to use water. And we've seen a remarkable change just in the last 2 or 3 years on the water use in for these and all this technological advances. And the pressure and the interest on the public side is only gonna keep improving on that.
Just wondering if you have any thoughts on that as well, Ed.
Yeah, the moratorium question is a really interesting one. And like you, I also don't take a position on it other than to say, in my experience, the places that are willing to have moratoriums are states where we have not seen a lot of data center development.
That's a good point.
That is true.
And so, at some level, I don't really feel like the moratorium debate is a major part of this. And I think in particular, what we really see is that the impacts of data centers cross state lines.
Hmm.
And so, I mean, to me, the perfect example of this is a state like Delaware, which has, does not have a moratorium, but has put a temporary moratorium in place, has been, I would say cautious is the way to put it, in attracting new data centers. And they are right next to Pennsylvania, obviously, who has been really going out and signing up a lot of data centers. And they're in the same market as Ohio and Virginia, where data center growth has been tremendous. And so it's not like Delaware can somehow hide from the financial and cost impacts of data centers just because, there's this fiction of state lines. The electrons don't care. And in a lot of ways, the dollars and the affordability concerns don't care.
Yeah,
because
that's true.
Delaware is buying electricity from the same market, the same regional market as the data centers.
Mm.
And so if the data centers are buying up all the cheap generation, or, it leaves Delaware customers without a lot of options. And so, I certainly think moratoriums are really an interesting topic and something that I think we will continue to see in certain municipalities where they're just not interested in hosting data centers. But I don't really see it being part of the national discourse on rate impacts, because unless we're about to enact a national moratorium or a multi-state moratorium, it just doesn't really change the struggles that we currently have.
I would agree with that. And I've seen it more hyper locally, actually, especially in New Jersey, with certain towns just saying no. And That's one thing. But then on the state level, a state like Maine, as an example, it got all the way to the governor's desk and she didn't sign it.
Yeah.
So, and that's another aspect of this too. But I guess backing up a little bit, a lot of my work is on cumulative impacts, usually tied to overburden areas, environmental justice areas, but more likely than not, that's not where these sites are going to go because there isn't the space for them. It's a larger possibility in my mind that we're talking about farmland, frankly.
Yeah.
And I have my own concerns as to what that could mean for local culture and food supply and things like that and food prices. But uh, do, do both of you think that the issues we're talking about here today are being thought of as cumulative instead of just on a site by site basis?
Oh, I mean, everything's cumulative, Chris. I mean, and we really ought to be thinking about that, from a planning standpoint and a transparency standpoint. It's all cumulative, and but we've kind of been living in that world for, I don't know, maybe the last decade. I mean, you could probably go the last 2 decades, as we've really tried to develop the sustainability concept, that kind of, goes hand in hand a lot of times with climate change, really, because it's like our world's changing and we all want to live here and we want generations to live here. So this cumulative understanding has got to be part of the story. And we can't just like one off and go, okay, well, we have this wind farm and it's over here by itself, or we have this solar field and it's by itself. It, the data center development has to be part of the whole infrastructure, sustainable on the water side, on the land side, on the energy side. So it definitely is cumulative.
Yeah, and on the power aspect there, Abe, do you have any thoughts on that as well? I would like from what I've seen, I would say yes to thinking about this cumulatively, especially on a PGM level. But I don't think enough people, especially locally, really understand that.
Yeah, no, that's absolutely right. I would say it's, the word the jargon is different, but the problems are exactly the same as what Jeff just said. And in particular, a small data center, 100 megawatts, you can basically fit that in around the edges.
Hmm.
Even a couple of hyperscale data centers, and you talk about hundreds, but we're actually even seeing gigawatt scale, so 1,000 megawatt scale hyperscale data centers. One of those, gosh, yeah, it's the size of a medium town. We could probably fit a couple of those in. But what we're seeing isn't just one or two or three. We are seeing gigawatts and even tens of gigawatts trying to connect to the grid in the next 2 or 3 years. And that's what's really breaking the system. And I think it's really important to recognize that PJM historically has had more generation than we actually need.
Hmm.
This is, we saw this in the form of very low electricity prices and capacity prices for a number of years. And we saw a lot of particularly coal-fired generation leaving the grid. Now, all of a sudden, the data centers are coming in and more than eating up the excess that we had, the spare capacity we had sitting around, such that we now need to be investing. And, these numbers are all over the map, but take your favorite McKinsey report, $1 trillion in new grid infrastructure over the next half decade. And in one way, it's a wonderful opportunity to, give the grid a glow up. Part of the reason I'm in this business is because I like big, sexy energy infrastructure. I think it's great. I think it's beautiful. I'm ready for it. And so the idea that we as policymakers can play with $1 trillion of new capital, there's some really exciting stuff we can do there. Governor Sherrill here in New Jersey has made a big deal about wanting to really animate the retail sector in New Jersey with distributed energy resources and putting batteries in people's houses and virtual power plants. All very, very exciting things that could have huge long-term payoff. At the same time, if we can get these new big tech companies to use their balance sheet to drive the grid upgrades that we need, to drive the clean energy investment that we clearly need to fund the next generation of offshore wind or nuclear facilities, like that would be a great opportunity for society. And the problem right now is that the data centers are coming in and moving so fast that we simply don't have those regulatory structures in place. And we don't have the plans for building out the grid, for doing the kind of clean electricity we would all like to see. And instead, we're kind of kludging it all together.
That's a great term, by the way.
What's that?
That's a fantastic term.
Oh, kludging, yes. Yeah, it's a good one. I mean, it really does. Like, I one of the things I do for fun is I go to PJM meetings. And, usually PJM takes 6 months to 2 years to debate a couple of lines of, what we call the tariff, which is kind of the Bible that governs everything they do. Now, we are taking entire sections of the 3,000-page tariff, ripping them out and trying to replace them with new structures that are going to allocate billions, tens of billions of dollars of capital. And we're trying to do it in a matter of months. And it is really a fascinating, sort of case study in change management.
That's great.
And the failure of bureaucratic institutions to be able to move at the speed of business.
Yeah.
And, and we as a society really do kind of have to decide, are we going to tell the data centers to slow down a little bit? Are we going to tell the grid operators and utilities to speed up? But I mean, this is kind of what happens. My friend Tom Ritigliano from NRDC says this all the time, which is what we have right now is we have the world's fastest moving industry colliding with the world's slowest moving industry. So we have the data centers on one side and the utilities on the other.
Yeah.
And, and that is just a really bad mix. And I'll throw bureaucrats in there. And as a former bureaucrat, I love my bureaucrat friends. But they also are having to move at a speed that they are simply not comfortable and ill-equipped to actually do. And it's because the data center, I mean, you can listen to the earnings calls from, take your big tech titan of choice, Google, Amazon, Meta, and they will tell you very plainly that their profit margins are being constrained. Their profit ability to make profit is being constrained by the amount of new data center load that they can bring on. So more compute is more dollars for them, and not just little dollars, like huge dollars. So the water issues that Jeff is talking about, the electricity issues that I work on, these are the things stopping them from making, let's just, obscene amounts of money. And so where you have that enormous profit motivation on one side, it's very difficult for regulators to step in and be like, no, actually, we're gonna make you wait. And so the question is, how do we take a little bit from each side and come out somewhere where I think we can kind of get to.
That's really interesting, and that helps explain one of the questions I had as to why these companies would be willing to invest such incredible amounts of money. But then I also have to play honest devil's advocate a bit and just kind of question if people understand the potential ripple effects here of sprinting to change everything all at once at the same time, and especially with something as pervasive as this. I think I mentioned actually in the opening, I have real concerns on workforce. Like I see a lot of people being out of work, and people call it a transition. Call it whatever you want. If that's a large number, I think we have to get people ready for that. But one other aspect I wanted to definitely get to, so I'm going to bring it up here. I've heard the argument from an environmental perspective that you can't only look at the footprint of a hyperscale data center, or better said, possibly system of them. you also have to look at the handprint and the potential efficiencies that can be gained by improving processes over time, using less water, finding new ways to do certain things. Um, First, do you put any stock in that argument? And do you think it's even viable to get there if they don't fix the social license tailspin that they're currently in?
Oh man, how
Yeah.
much time do we have? Because I feel like you just asked 2 hours worth of questions. But
I did
so
it.
my my favorite story. So for those of you who have heard me give a podcast before, you're going to be really bored by this. But my favorite story is a story from the early 2000s where Amory Lovins, who is the sort of sage of energy efficiency, who founded Rocky Mountain Institute, now RMI, had a debate with a couple of analysts who were saying, once we get 1 billion devices hooked up to the internet, they are going to use more electricity than the whole rest of the country combined. So it was very much, it really sounds exactly like the conversation happening today. And of course, today I probably have 1 billion devices hooked up in my house, right? We have way gotten past the billion device mark, like by orders of magnitude. And what happened? Well, did the electricity system crash?
No.
No. The chips got really efficient. The mechanism for transmitting the algorithms got more efficient. Every piece of the chain got more and more efficient. And and the packet technology for sending data over the airwaves got more efficient. It is very reasonable to assume that data centers are going to get more efficient over the next 30 years, which is really when we talk about an energy investment or a piece of infrastructure investment, we really are looking over that 20, 30, even longer life cycle. And so where we have, data centers coming in saying today that they want tens and tens of gigawatts of electricity, for how long and how certain is that? And a lot of my work is planning under uncertainty. Because what could happen? There could be a cyclical downturn in the data center industry. I mean, like nobody saw the dot-com bubble until it happened. That's one possibility. But equally as likely, if not more likely, is the idea that the data centers themselves are going to get much more efficient. Because right now they're sort of brute forcing everything. And as the algorithms get better and the research gets better, DeepSeek came out a year or two ago. And we all thought, oh my God, this is the end of the AI revolution, right? A lot of things can happen that have absolutely nothing to do with us using less AI that would still result in lower AI energy consumption. I mean, I'm pretty sure, I'm not a computer scientist. I don't know anything about any of this stuff. I am pretty sure that sometime between now and 2050, we're going to have some sort of quantum computing.
Oh, yeah.
What does that do?
Yeah,
I
probably
have no
sooner.
idea. And so the challenge for us isn't necessarily being right about how much electricity data centers are going to use. It's making sure that retail customers, that grandma is protected financially from higher electricity prices, whether the data centers end up using more electricity or less electricity, or whether they all go out of business tomorrow because there's going to be a singularity. I obviously have no idea. But these are the kinds of things that we as policymakers need to put into place today to stop some of these adverse effects from really making people's lives worse. And you asked plenty of questions about like long-term employment. I don't even touch that stuff, right? I'm happy over here in my little energy rate bubble, but it does have just huge implications for people's quality of life if electricity rates keep going up the way they are right now.
Yeah. And we see the same thing on the water side. You can just go back last year, 2 years ago, 5 years ago, and the efficiency continues to improve. And the water use considerably is improving. And I mean, it wasn't that long ago that data centers, it was a pass through. They took the water from the municipality, they ran it through their system and they discharged it. And it was, they don't do that anymore. They're looking at, okay, let's reuse it, let's reuse it, let's reuse it. A growing technology is if they can't get water from the municipality, then they pump water out of the ground, they run it through their system, and then they put it back into the ground, they just cycle that, and it doesn't use a lot of new water because they continue to cycle it. So that technology is going to continue. We could have a system, not into the very far future where it uses little, if any, water, but traditionally, Chris, the the less water we use, the more energy we use. It's kind of this balance on the cooling side. So, we're going to use less water. Now our energy increases because now we're using more electricity to cool the system.
Mm.
So there's this balance. California, passed a law that all new data centers in California will not use water. I'm like, okay, then all you're going to do is jack up the electricity costs because now has to be cooled in a different fashion. So, but to answer your question, we will continue to see improvements in efficiency on the water side, and that's great.
And Jeff, one of the things that I'm very excited about is Maryland just adopted a new statute. There's a lot of details, but one of the things they did is they established gold and platinum tiers for data centers.
Great.
And I think we are going to have, within the next couple of years, a, LEED certification for data centers. And it needs to incorporate the water side and the energy side and the efficiency side. And, and it's probably not going to be a number because, to Jeff's point, if there's a lot of water available, the calculus may be different than in a desert area.
Exactly.
Right.
Yeah,
and these things need to be accounted, but we need a structure and hopefully one that is almost like a building code that various states can, reference in their own rules. Because right now it's kind of like every state is out there fighting this battle themselves.
Yeah.
And it would be much better to take those efforts and combine them and have a central body establishing these rules, working through all the details that then states can reference. Because again, we often talk about speed to power on the data side, but we also need speed to regulation.
Yeah.
Sure.
And anything we can do to get that speed to regulation faster and to match with the speed to power movement is just really important from a public policy perspective.
Yeah,
well, that's a great.
folding that into like a lead program, Energy Star, that's great because then there's something to work toward, right? It's like instead of this myopic, oh well, this is how we did it, So yeah, we did that with buildings.
That's right.
A fantastic
And you can
approach.
have stretch codes too, right? I mean, one of the
Yeah.
things, for a municipality that really feels
Fantastic.
strongly about energy efficiency and clean, they can have a challenge code or a more stringent stretch code. Like these frameworks exist. They just need to be applied to the new sector, and somebody needs to come together and form that sort of standard setting body and hopefully get buy-in from a whole bunch of regulators and the industry that they're going to come in and do this.
Yeah, and I think the public can get behind some that kind of thing.
Yeah, totally agree.
And that's a great segue, actually. I put together a team at Rutgers to do exactly that type of thing and hopefully put a toolbox together for policymakers based on what's been happening thus far, what has worked, what hasn't, and what guardrails, to actually use the term of the day, can be put in place to do this smartly. Because again, I'm not for or against, but I understand the impact that this is going to have and has had actually already. So the goal of the work is to have this toolkit in place for anyone who wants to come and have a totally unbiased, here it is, here's the best practices currently, here's the types of things you should be thinking about going forward, and ideally over time, as you both are alluding, things are going to better and they're going to be different best practices, you could always just update that. But I think having that spot for people to go that isn't biased, that isn't being funded by datacenter.com or whatever you want to call it, can go a long way.
Yeah.
But on that climate piece, though, just to hammer that home a bit more and I guess play a little bit devil's advocate, in my opinion, a lot of the potential handprint stuff, to go back to the analogy, is only going to be realized if we have some rules in place for the people who use the LLM processing power. The customer can come in and use them for whatever they want, essentially. Don't we also have to tell them that, hey, you guys have to also be looking into innovation, environmental aspects, dedicate a portion of your capacity or time towards finding a better way to do all of this?
Most definitely. Yeah. The climate impact is fundamentally a power sourcing issue.
Hmm.
And so I think that is the message that has to be shared and understood. So uh, whether you put guardrails on there or incentives, I mean, some states like Pennsylvania, that's what they're like, okay, we're just going to go through the incentive, route. And so, is it real? Yeah, it's real, and anytime you have growth, you're going to affect climate change. So you have to acknowledge that, and you have to, and then there has to be that open discussion. Okay, so what does this mean? And if we just recognize and accept it, and then come together and figure it out, and say, okay, how do we make this work? And it's planning. It's planning and having the appropriate stakeholders involved in the planning, and it's transparency on the water side, transparency on the energy side, and that's how we address it, and that's how we move forward.
I definitely want to leave time for the final thoughts and last questions and all that. But I wanted to ask you guys a variation of something I've been bringing up a few times now. Personally, my biggest concern on these topics is tied to workforce. Is there a biggest concern actually you guys have? Because it's been relatively positive thus far. Just kind of challenging a bit. Is there anything that you're worried about? Anything that you think should be focused on more than it might be currently?
I mean, for me, it is yeah, it is the wholesale replacement with in the policy arena with the discussion of climate change, with the discussion of how do we power data centers.
Hmm.
Like I'm not happy with that. Like I think that's not great. And while I do think it is possible that data centers could drive a lot of investment in clean energy, the real danger is that they drive a ton of investment in natural gas. And I do think we need to recognize that there is a bit of a trade-off, or not a bit of a trade. There is a trade-off we are making here between our long-term climate goals and powering AI.
That also
And like I
localized
don't want
health
to lose
impacts as
sight of
well.
that. I don't want to lose sight of that, even as we sit here and talk about how do we do this in the best possible manner. It is really important that we make sure that the investment that's happening, this $1 trillion or whatever we're going to spend over the next few years, is done in a way that is as climate positive as we possibly can.
Agreed.
And like that is absolutely critical. And the second thing, and I often actually start my conversations with policymakers about this, is the affordability impacts really hit low income customers the most.
Absolutely.
And I feel like there's a whole lot of stories about how grandma's foregoing her medication to pay her electricity bill. But you know what else happens? There is now really good research that looks using smart meter data, looks at how customers interact with their own electricity usage, particularly on hot days. And the fact is, a low income customer waits longer before they turn on their air conditioning than a rich customer does. And they break it down basically by $10,000 income chunks from 30 to 150,000. And by the time you're at 150,000, you're basically flat. You're staying at a balmy 67 all year round.
That's freezing.
And when you get to those lower income brackets, you're seeing people are waiting till the temperature gets to really uncomfortable levels before turning on their air, if they even have it. And so I do think it is like absolutely critical that we keep in mind that there are real human impacts here, and that the affordability issues aren't sort of swept under the rug, and that we are insisting that in exchange for helping the data centers meet their commercial goals, that we're not internalizing all the profit motivation and externalizing all the bad stuff.
Yeah, so I think that's right. Jeff?
In a lot of ways, Chris, the data center, which is, the news of the day, it isn't much different than, everything that we've seen over the last couple hundred years or 300 years. I mean, there are components that make us go, okay, how are we going to deal with this? How is this going to change our life? I like to think that computers have really affected and on a positive sense on our society. It has changed the way we do. And you look at jobs, and you go, okay, what is it, 20, 30, 40% of the jobs today did not exist, X number of years ago. And in X number of years in the future, X percent of the jobs now won't exist. And it's like, but we will adapt. We'll figure it out. It's not going to destroy us. And the whole idea is that hopefully it makes us better, and if we can come together and as a society and talk about the challenges and solve those, uh, on the energy side, the water side, the land use side, with the EJ component, with a sustainability lens, it's totally doable. We've existed for a long time, and we're going to continue to exist. So we just have to make smart choices.
Okay, I could go on forever, frankly, talking with you guys and talking about these topics, but I want to be conscious of the time here. I want to allow you both time for final thoughts, and also because our biggest demographic is young people under the age of 25, roughly 35% of the folks who listen to this program. That age group has a lot of concerns and questions about this, about the world that they're going to be walking into, inheriting, frankly, from us. Is there anything you'd want to say directly to them on the topics we've talked about here?
Yeah, I'll go first, and then Abe can close us out. But I think the key takeaway is that data centers are fundamentally different, or aren't fundamentally different from other large infrastructure, right? They just bring everything into focus. They force us to think about how fast we're growing, how we manage water locally, and how transparent we are in the process. Okay? If we get those pieces right, there's no reason that data centers and sustainable water use can't coexist, right? If we don't, then the conflicts we're seeing now will just become more and more common. Okay? I think the risk isn't that data centers are growing. It's that they're sometimes being planned, like Abe said, they're sometimes being planned faster than our infrastructure systems can keep up. Okay. Water in particular is a local resource. Okay. You can't move it like electricity across the country, and you can't scale it very quickly. Okay?
That's a good point.
So So when large users come into a system, the question becomes not just how much water they use, but when they use it and who pays for the infrastructure required to support them. Okay. But the good news is we have the tools. Better planning, alternative cooling technologies, groundwater management strategies, they all address these challenges. And we just need to be brought in at the beginning of those processes. And if we do that, then the growth can be technically sound and socially sustainable. And to, a large group of your listeners, Chris, you know, get involved, learn, be curious, but also listen to all sides. Okay. Because if you're curious, you'll learn that it's not just you're right, you're wrong.
Yeah,
And so be curious and listen and but also be passionate. And I love that about the younger generation. My children are extremely passionate about sustainability, and that is fantastic, because it keeps me in check, right? Keeps us old people that this is how we've done things. It keeps us in check,
sure.
and so um yeah, no, it's been great. I've really loved this conversation, and I think it's really important.
Excellent.
Yeah,
Well,
and I'll just add on to that. Particularly for young people. I mean, the reason I went to academia after I left government this last stint was because we really need to get young people interested in jobs, particularly jobs in government, fixing these problems.
yeah,
I could think of no place where you will have a bigger impact than going, and not even necessarily, like that well, it used to be sexy federal job in DC, but like, going to work for your local public utility commission. You're going to get responsibility like you could not believe. In a way, it's almost a little bit scary. I mean, when I was in New Jersey, our entire, multi-billion-dollar solar program was being run by, I think, a 28-year-old who was absolutely brilliant. And she did it. She managed it, and it worked out great. But like that is something that you really don't get anywhere else. And yes, the jobs don't pay great. They're often in kind of like drab government buildings, and it's easy to get sort of easy to
You're
sort
not
of get this.
selling it.
Yeah, well, yeah.
Come on,
No,
Abe.
that's right. No, that's right. That's right. But like my challenge to you all listening to this is if you care about this stuff, go on and fix it.
yeah,
And you may have, a bunch of different ways you want to do that. And there's certainly no limit. But one of those is take classes in this stuff, really understand it.
amen.
Go work in industry, go work in government, like, get the right people in to actually do it. Because, my experience is so many people want to talk about this stuff, but there's just a really small number of people who actually are willing to sit there and do it. And
Yeah,
so be one of those people.
absolutely. I think that's a great spot to end. I want to thank you both for what's been definitely an informative chat. And just sitting back here, I could think of a lot of people who were going to enjoy this and get a lot out of it. And then there are frankly some who are going to be upset by it and not like everything we said here today. And that's okay
Yeah.
too, because this is what the attempt is to try to play it down the middle. And I think
Yeah.
everything we talked about here today is important and hopefully advances the conversation on all these topics. So thank you again, everybody.